Hello, everyone. Welcome to week number 2 in Science 200. We are going to delve a little bit further into our topics this week, and you've got a good bit of reading to do in your web text. So let's see what we've got going on. Oh, here's a picture of a sea eagle in Scotland. It was flying down low, aiming for the puffins that were on the rocks. This is an extremely rare type of picture to get because sea eagles are usually way over the top of the cliffs looking for prey. And I was on a boat that was rocking back and forth when I took this picture. So I have no idea how I got it. But anyway, I did. All right, let's see what we've got. So last week we learned what the natural sciences are. Biology's at the top of the list, but chemistry, physics, geology, astronomy, and environmental science. You learned about how science works, and I explained that in my video that it's more complicated than what you learned about in the 7th grade. And it's a very long process. It takes a lot of time to do proper science, and there are lots of checks in place to make sure that everything is proper and right and ethical and professional, etc. Plus, your results are validated by other scientists. So you learned about how science works and the importance of revision. You're going to learn that this term because every week you get a chance to revise what you have done and turn back in the revision. And that's so that when you get to week number 6, when you turn in your final paper, that you can actually turn in a perfect paper because you've already turned it in week 5 and gotten feedback. So you can fix it. And week 6 is a huge point value assignment where week 5 is not. So revision is really important in this term, and we do this a lot in science. You learned about Alexander Fleming and penicillin, his discovery of penicillin, and of course that was my favorite story in the textbook for last week, since I'm a microbiologist. But it's a great explanation of how science works. And sometimes scientific discoveries are just serendipity. It just happens by chance. But you have to be prepared to recognize what you are seeing. And that's what Alexander Fleming did with penicillin and that mold that was growing on his petri dishes. You started your research topic, you mentioned what it was, and so I'll be grading those this week. And this week you're going to continue that. So let's see what we've got going on. So this week, chapter 2 in your web text is fairly long. And if it were me, I would break this chapter up into chunks. I would not sit and read through all of this at one time. I would break it up into chunks and go section by section and answer the questions for that section before I moved on. That's just me because it's a lot of reading this week. It's the most reading of any week that we have in the term. But it is very interesting. I mean, I love it. It's all about public health, and I worked in public health for 11 years. Plus, it's microbiology also. So anyway, it's all about cholera. Cholera is a type of diarrheal disease where you end up with something called rice water stool, and that just means that it's basically clearish, whitish, milky looking water that's flowing out of your body uncontrollably. And of course, you can die from dehydration very quickly because of this. Your heart can stop and all sorts of things. So it's a deadly disease. Now we know that it's carried through contaminated water. That's almost always the way that you come in contact with cholera, Vibrio cholerae, which is the species of bacteria that causes cholera. You're going to learn about sanitation in London. So when societies changed from agriculture to more industrial, like London did, people flocked to the big city to work in the factories. And they had to have a place to live, and a lot of them lived in the tenements, and there was not good water supplies, and there was not a good way to dispose of their garbage and their sewage, etc. Except through the River Thames that ran through London. Clean water was an issue. Now, there were wells. There was a well system throughout London where you could get water in your neighborhood. However, your sewage also dumped into the River Thames, which is exactly where you got your water supply from. So you can see where this is going. It is not going to be good, and it was not good. It depended on where your water came from and where all the sewage was going into the river. So anyway, clean water was not completely accessible. And when it wasn't, then you were likely to develop cholera, and so were the people in your family and your neighbors, and just whole huge neighborhoods were affected by cholera, and there were many deaths in London during this time from cholera. I'll mention miasma. So the leading theory about how diseases were spread back then was through miasma. So miasma is, the best way to describe this is stinky odors, right? Nasty smelling odors. So you could smell diseases in the air. Now, of course, we know that there are diseases that are transmitted through aerosol droplets through the air. Cholera is not one of them. But the leading thought process about disease transmission was through miasma. And so they thought that all diseases were spread through these stinky odors. And if you stayed away from stinky odors, then you wouldn't come in contact with diseases. One reason that they thought this is because rich people who lived in houses that were far apart from each other didn't experience these stinky odors because their sewage was taken care of pretty well. And so they didn't come down with cholera as much as the people in the tenements. So, there was some evidence to indicate this, but some people didn't think that that was true. They thought that it was coming from contaminated water, like Dr. John Snow. And he's really important in our story because he shows through his data, through mapping out the cholera cases, through mapping out where the wells are, through mapping out where the sewage was going into the Thames. He showed that the cases of cholera were coming from particular wells that were contaminated. So this was extremely important. And what's so important for you to get out of this is that science is data-driven, not opinion-driven. Okay, we have a whole lot of that in our world today. Everybody has an opinion, and a lot of people are completely uninformed because they don't look for any research, they don't look for any information, they don't look for any data. And that's terribly important in science. Science is data-driven. John Snow did this and showed that cholera was transmitted by contaminated water sources, and that was the wells in some of the neighborhoods in London. Public health was basically formed during this time that helped ensure that people had clean water, ensure that people had good sanitation, that garbage was picked up and disposed of, and that sort of thing. And this shows you how science works. That's another reason that we have it in chapter 2. All right, then for your topic, notice you don't have any discussion board postings this week, but you have something to do for your topic. What you're going to do is develop a research question. So you're going to ask a question. You're going to figure out a question that you're interested in exploring that has to do with your topic. So if it's ocean acidification, for example, you might think, well, how are the coral reefs affected by this? If you're interested in electric vehicles, you might say, well, what is the actual carbon footprint of an electric vehicle? If you're interested in commercial nuclear energy, you might want to know, well, how safe are they? So you're going to come up with a question about your topic that you're interested in exploring. And that's what you're turning in this week. Sources for research. You need to be researching your topic now. And do not just do a Google search. You are going to come up with a bazillion pieces of information out there, and a whole lot of it is not any good whatsoever. So don't do that. You get a lot of opinion pieces when you do a Google search. So instead, here are my sources that I'm going to refer you to. First of all, the Shapiro Library, our library. It's free. You get access to lots and lots and lots of free full text articles, which is absolutely amazing. I mean, I use it because you get free, complete articles from the library. Otherwise, you have to pay for these when you're out there in the world. So the Shapiro Library is wonderful. The trick is always going to be to figure out the correct words to use in your search so that you find specific articles and information about your topic. But the Shapiro Library is number one. Google Scholar. So not a Google search, Google Scholar. Google Scholar is very good because it will bring up all types of scientific articles and science out there that has been done on your particular topic. So Google Scholar, very good. Also PubMed, another database. Now, Google Scholar and PubMed both, you'll find the abstracts to most of these articles, but you're not going to find the full articles. A lot of the time, all you need is the abstract, and we will be talking about that. It's coming. But just realize you have different ways to do searches to find information on your topic besides just doing a Google search. Please don't do that. It's going to be ugly, I promise. And you're not going to find good information, good, credible, reliable information, and relevant. All right. So that's week 2. My tip of the week, especially with your readings this week, is to break up your assignments into manageable pieces. You're sitting there waiting to go in to your dentist office, read for the 15 minutes, read your textbook for the 15 minutes. You can read it on your phone. Maybe you have your iPad with you. Maybe you have a lunch break at work and you're just sitting around with nothing to do. You could fiddle around, look at some TikTok videos, but you could also do part of your chapter in your textbook. So break up your assignments into manageable pieces so that you can get your work done throughout the week. All right. Oh, aren't these puffins cute? Yeah, these are what the sea eagle was aiming for, and it actually caught one, but it didn't grab hold of it very well, and the little puffin was released and tumbled down the rocks and got up and waddled off, which was so cute. Oh, my word. Puffins are so cute and funny. Watching them fly is just hilarious. But here they are. I took these pictures in Scotland when I went there. Anyway, I hope that you have a wonderful week this week, week number 2. And if you need anything, you're having any trouble, you're struggling, please let me know. m.sigmon@snhu.edu. I'm here to help you. I'm here to help you learn. And I'm here to help you solve problems if you have some and you need some help. Please just let me know. All right? I hope that you have a wonderful week number 2.